Welcome. This is just a quick review of rules for exponents. All of this is in your notes. All right, so e is a number. The same rules for exponents apply to e as apply to any number or variable. Because even a variable just stands for a number. All right, so if you multiply like bases, and here I'll make a handy dandy arrow so you know where I'm talking about. If we multiply like bases raised to a power, you add the exponents. It doesn't matter whether that's a number, a variable, or e, right? When you multiply, you just add the exponents. Anything to the 0 power, including e, is just 1. If you raise something to a negative exponent, it makes it the reciprocal, right? If you divide something, divide bases raised to a power, you simply subtract the exponents. So to divide like bases raised to a power, subtract the exponents. And it doesn't matter whether that's a variable, a number, or e, which is a number. And finally, if you raise a power to a power, you multiply the exponents all of the time. All right, a little review for exponents there because that might come in handy as we look at working with e. One last thing, let's look at growth and decay for e. So I have some answers up here, and actually I'm going to hide the bottom slide. Maybe I was quick enough you didn't see the bottom. All right, so let's see if you can figure it out before I move the slide down. So what makes a natural exponential function a decay function? All right, so f of x equals e to the negative x, that's decay. F of x equals e to the x, that's growth. F of x equals negative e to the x, that's growth. And actually, I'll add one here. You have this in your notes. You can add the one I'm going to add. Oh, so don't look at the bottom of the page because I forgot it's in your notes. I'm not shielding this very much from you, am I? All right, so but don't look at your notes. Now I guess you can look at your notes, but don't look at the bottom. F of x equals negative e to the negative 1/2 x. That's decay. So have you figured out what makes e growth or decay? All right, so let's rewrite these. So f of x equals e to the negative x. That's the same as 1 over e to the x. Right? And likewise, the bottom one there, f of x equals negative e to the negative 1/2 power, that would be the same as negative 1 divided by e to the 1/2 x. Right? So we remember what e is, right? E is equal to 2.718 and then so forth. All right? So if I have 1 over, so if I've got e to the x there, if it's even e to the first power, and our x is 1, that's going to be equal to 1 over, approximately equal to 1 over 2.718. Right? That's smaller than a half. Right? So we're getting closer, right, to the x-axis. And if x gets larger, right, if I square it or I cube it, or it's 3 or it's 4 or it's 5 or it's 6, that value is going to keep getting smaller and smaller because my denominator is getting bigger and bigger. Right? It's like a cake. Right? You have one cake. You cut it up into 2 pieces. That's not so bad. Right? Yeah, that's a pretty big piece of that's a lot of cake. You cut it up into 1,000,000 pieces. Well, you don't even have a crumb. It's like getting nothing. Right? And likewise over here, if we had negative 1 divided by, and x is 1, when x equals 1, we'd have negative 1, and then we'd have half. right? So now it would be 1.409. Right? And that's smaller than 1. Right? And so imagine as x is getting larger and larger, same thing is going to happen. All right? So I'm sure you figured it out that if e is in the denominator, then the base is between 0 and 1, and the function is decay. All right? So anytime you have a negative exponent for e, it's going to be decay. In the next series of podcasts, we'll look at graphing with e as a base. But thanks for watching this introduction to e. Bye for now.